Welcome to my new calculus channel. My name is John Gabriel. And you won't believe it, but there are still some people out there who are telling me that in my definition of derivative in the new calculus that I divide by zero. No, it never happens. So let me explain to you one last time. Right. So you see, m is a distance from the tangent line to this endpoint, to the endpoint of the secant line, and n is a horizontal distance to the endpoint of that secant line. This is the point of tangency. This is the new calculus derivative. There is never division by zero here. So see, this gradient here is always the gradient of the tangent line. It doesn't matter where it is, okay? It's always the gradient of the tangent line. So it doesn't matter how close I get there. There is no secant line with a 0, 0 pair. In other words, there is no secant line such that this is 0 and this is 0. See, there can't be, otherwise it's not a secant line. See that? If it was 0, 0, exactly there like that, well, can't get it dead right. But if it were 0, 0, then you'd have division by 0, right? But it's never 0. So then you tell me, well, then how do you know it's correct at the point of tangency? Well, look, this is how I know. When I'm calculating the gradient of a parallel secant line, I'm using this form, okay? But now, in this particular format down here, I know that q of x, m, and n is 0. I know that. I have proved it to you, okay? So I don't use this form here when I'm calculating when I'm at the tangent line. I don't use that form. I use this form down here, in which case I know that this here is 0, all right? And it doesn't have to be, by the way. Even down here, see what happens? Look at this red line down here. I can put any one of the infinitely many pairs in this line here to make this 0. It's never 0. X, m, and n is never 0, but this expression here is equivalent to 0. Do you understand that? So m and n is never 0 in the new calculus. I never divide by 0. You do that only in your bogus calculus, but it never happens in the new calculus. Does that make sense? Okay, so I've actually proved that this expression here is 0, and you know, seeing is believing. Watch this and look down here. It's always 0, see? And it doesn't matter, of course, the auxiliary equation will differ for different functions. It's not all the same, but it doesn't matter where you are. It doesn't matter how you move the tangent line, wherever you move it to, it's always going to be 0, okay? So in the new calculus, there is never division by 0. If you don't understand that now, you never will. But you won't believe me, there are still stupid people out there, especially on sci.math, who think that I divide by 0. No, I never divide by 0. See, no secant line here can have a 0, 0 pair. Otherwise, it's not a secant line. Do you understand that? And I'm calculating the slope of the gradient by taking the slope of the parallel secant line, which is always correct, okay? It's always correct. See, never changes. There's nothing approaching. These secant lines don't approach that point. There's no limits, nothing like that. Nothing is approaching anything like you have in the bogus calculus. Okay, well, I hope I've cleared that up once and for all. And if you don't get it now, well, you're too stupid then. I'm John Gabriel, and this is New Calculus. Till next time, goodbye.